Hello, I welcome you all. The problem reads determine the normal and frictional driving forces that the partial spiral track exerts on the 200 kg motorcycle at the instant theta equal to 5 over 3 pi rads and theta dot equal to zero point 0.4 rads per second and theta double dot equal to 0.8 rads per second squared. Neglect the size of the motorcycle. This problem is coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. Right, so we are being asked here to determine the normal force and as well as the frictional driving forces. So let's say draw a tangent line, maybe somewhere there like so. Maybe something like so. And then draw this force this direction like so. Okay. And then we have the normal force, right? And then we have this coordinate, okay, and then we have another coordinate, okay, and then what else? Right, so this is okay for now, but we do have right, so let me show the coordinates. So we do have this one, which is our radial coordinate, and this one, which is our theta coordinate. So this is our theta and this is our r, and this one here is our normal. This is our normal force. This is our driving friction force. Okay, right, and then we do have this angle here. We have this angle here, this one here. So this one is our psi. Okay, so if this is our psi, then there is this angle here that I'm going to call alpha. Okay, this alpha here is the same as this angle here. Okay, this is also alpha. I'll explain what this is. Okay, and then I will have the weight. I do have the weight of this motorbike acting through the center of gravity. Let's say that is the weight of the motorbike. Alright, so we are going to have components. We are going to have components for each of these forces. Mind you, this one here goes the other side like so. I don't need to show that. It goes like so. Alright, so let me just wrap this there. I put it somewhere here. This is our driving frictional force. Okay, what do we have now? Let's partition the components. So we do have, let me just write this one so that it doesn't disappear. Okay, so we'll have a component of n in this direction. We do have a component of n in this direction like so. Okay. Right. Okay, of n will have one component like so in that direction, and another component like so in that direction. This is for n, and then we'll have components for w, which is the weight. We'll have one in this direction, and then another one in this direction. This is for the weight. And then for f, we'll have one in this direction. We'll have one in this direction, okay, and then another one in this direction. This is for F, the force. Okay, let's label this. So we say this is our weight W, and then we do have another angle that we just need to define. This angle here, this angle here, this angle here is this angle here is theta. I mean, it's I'll call it beta. Okay, which is equal to this one here, beta. Okay, right? This is beta. So this is beta, then this becomes 90 minus beta, therefore this also becomes beta. Okay, right. So this one here is also beta. Alright. So let's label this. Let's start labeling them. So let's start with n. N, we said it has 2. One is this one here. So this one we are calling it n cos alpha, and so is this one here. This is n sine alpha, and then we do have this one. This one is f. This is f. This is alpha here, right? This is alpha. So this is f cos alpha, and then this one here is f sine alpha. Alright, and then we do have this one, the weight. This is w cos beta. Alright, this is w cos beta, and this is w w sine beta. Right. Okay, I think we've done everything. We have the force, 2 components. We have W, 2 components. We have the normal force, 2 components. Alright, I think this is okay. So now let's define what these are. So we are saying alpha is equal to 90 degrees minus psi. Let's define what psi is. So we know that tan psi is just equal to r divided by the r, the theta, right? And we know to say our r is just equal to our r is equal to 5 theta. Okay, and therefore the theta is just equal to 5. Therefore tan psi is just going to be equal to 5 theta divided by 5. Okay, at theta equal to 5 divided by 3 pi. And therefore our psi will just be equal to, so this and this goes, therefore we'll have 5 divided by 3 times pi, tan inverse of that. So we have 79.19 degrees. Therefore alpha, like we said, is equal to 90 minus psi, which is equal to 90 minus 79.19, and this just gives us equal to this is a 10.81 degrees, right? So 5/3, okay, that's 5/3 times pi, tan inverse of that 79.19, and then we subtract a 9 to 10.81. All right, and then beta is just equal to let's define the angle first. This angle, I want it in degrees, is 5/3 pi rads times 180 degrees divided by pi rad. So if we converted it to degrees, this just becomes theta equal to pi divided by 3 times 180, just becomes 300 degrees. So beta is just equal to 360 minus 300, and this is just equal to 60 degrees. Great. So now let's work out the inputs to the acceleration before we apply the equations of motion. So I'll say my r is equal to 5 theta, and therefore my r dot is just equal to 5 theta dot. My r double dot is equal to 5 theta double dot. Okay, let's find these values. R at theta equal to 5 divided by 3 pi. This just gives us the 25 divided by 3 pi, and then r dot at theta dot equal to theta dot equal to 0.4. This is just going to be equal to 2, and then theta double dot, r double dot at theta double dot equal to 0.8. This is just going to be equal to 4. Right, so we have everything. So let's just do work out now. Write down the equations. So our ARR is equal to r double dot minus r theta dot squared and this is equal to f4 minus r, which is just a 25 divided by 3 pi by theta dot squared. Theta dot is just zero point 0.4 squared. Therefore, our ARR is just going to be equal to 4 minus 25 divided by 3 times pi times 0.4 squared. So this gives us a minus 0.1888. Okay, then we have a theta, which is just equal to r theta double dot plus 2r dot theta dot, and this is just equal to 25 divided by 3 pi theta double dot, which is 0.8 plus 2 r dot, which is a 2 theta dot, which is 0.4. Okay, so we have r, we have theta double dot, then 2 by 2, then by theta dot, which is 0.4. Okay, so 25 divided by 3 times pi times 0.8 plus 2 by 2 by 0.8, by 0.4. This just gives us a 22.5440. Alright, so there we go. Let's apply the equations now of motion. We have found these values, a r and a theta. We can now use these equations later on to do the calculations, right? Let's close up this. Okay, so we can say summation of forces in the r direction is equal to ma r, our r which is going down like so. Then we do have the following in the r direction. This is the direction of our motion. So this one is m a r, this is our m a theta. So what do we have in that direction? Let's start with w sine beta. Okay, then what else do we have? Then I'll say minus n cos alpha. Okay, and I'll say plus f sine alpha. Where is my f? There it is. Okay, so these are both positive and this one is negative, so this is equal to MAR. So this one just becomes a 200 by 9.81 sine beta, and our beta is 60 degrees minus n cos alpha, and our alpha is just 10.81, and then we have f sine alpha, which is 10.81, equals m, which is just a 200 by AR, and our AR is equal to which is our AR equal to. Okay, our AR is equal to minus 0.1888. So let's simplify this. So we do have um, cos 10.81, right? So this just becomes a minus 0.9823 n. Okay, then I have plus, do have plus, sorry, this is minus, this is minus n. Let me check n. Of course it's minus, and I have plus f. Where is f? F is positive, so that is sine 10.81. So this is just 0.1876 f, and this is equal to 200 times 0.1888. Okay, and then we have 200 by 9.81 sine 60. So this just gives us this value like so, 90. Okay, so let's work out the other one. So it says summation of forces in the theta direction equal to m a theta going up in our reference. So what do we have? W, where is W? So it's minus W cos beta, and then N. I want them to be in that order. Where is our N in this direction? Okay, so it's plus N sine alpha, N plus F cos alpha is equal to M, like so. So this is just 200, 9.81 cos beta, which is 60, plus N sine alpha, which is 10.81, plus F cos alpha 10.81 equals 200 by A theta, and A theta is 22.5440. Alright, simplifying this, we'll get following. Sine 10.81. Okay, this is 0.876 n, right? Then we have plus cos 10.81. This is 0.9823 f, and this is equal to 200 by 22.5440. Okay, plus 200 by 9.81 cos 60. So we get 548980. So we are going to solve these two equations, which I'm going to just arrange. Okay, so I'll have this one here like so, and I'll get this one also. I bring it here like so. So I'm going to solve these two equations. simultaneously, right? All right, so let's solve them. So I'll bracket them like so. Okay. So let me say I multiply this by 0.1876 and this one by 0.19823, and I sum them up. Okay, I sum them up just using substitution method, right? So let's do so. If we do so, of course this part goes, right? Multiplying that. So let's work out the other one. So we have 0.1876 squared, okay, plus 0.9823 squared. Okay, so this gives me f is just going to be equal to minus 1736.90 by 0.1876 plus 5489.80 times 0.9823. Okay, so this gives me a 5066.79 newtons. All right, so we have the force in the same direction. We can calculate n. Okay, let's calculate n. You can use either of the equations. I'll use just the bottom equation. So I'll say 5489.80 minus 0.9823 times 5066.79 then divided by 0.1876. So this gives us a 2732.90 newtons, and this one is in this direction like so. All right, I think this is about it. We found both the frictional force, the frictional driving force, as well as the normal force for this particular problem, and I hope the video was helpful, and if it was, give me a thumbs up, like the video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.